Hello friends, in this video I am going to solve exercise question from book Topics in Algebra. This question consists of two parts. So part A is given any group G and a subset U, let U cap be the smallest subgroup of group G which contain U, then prove that there is such a subgroup U cap in group G. We call this U cap as a subgroup generated by U. So proof. Here G is a group and let UK be any subgroup of group G which contains subset U. Now consider I be any index set of all such subgroups containing U. That means for any I in set I, UI will be a subgroup of group G containing U. This is the meaning of index set. Now note that G will be equal to UK for some K in index set I, because as G is a group, so G is subgroup of itself and therefore G will be a subgroup of itself which contains the subset U of group G, and therefore G will be equal to UK for some K in I. This is only the additional information. Now for all subgroups U alpha in group G containing subset U, consider intersection of all such U alpha and we call this intersection by U cap. Then note that this U cap will be the subgroup of group G containing U, because we know that if H1 and H2 are any two subgroups of group G, then H1 intersection H2 will be again a subgroup of group G, and we can generalize this result for any number of subgroups of group G. So here U cap will be a subgroup of group G, and since U is in each U alpha, so U will be in their intersection and therefore U will be in U cap. So U cap is the subgroup of group G containing U. Now next we need to show that this U cap is the smallest subgroup of G containing U. For this, just observe that if K is any subgroup of group G containing U, then U cap will be a subset of K, because K will be then some U alpha. So from here we have U cap will be a subset of K, and therefore we get U cap is the smallest subgroup of G containing subset U. Now we will find nature of the subgroup U cap. For this, consider a subset, say H of group G, consisting of elements of the type U1 to the power K1, U2 to the power K2 up to so on UN to the power Kn, where each UI is an element in subset U and these K1, K2, Kn are integers. Now we will show that H is a subgroup of group G and we will characterize U cap with this subgroup H. So to show H is a subgroup of G, consider any two elements, say A and B in H. Then A will be equal to U1 to the power K1, U2 to the power K2 up to so on Um to the power Km, and B will be equal to W1 to the power P1, W2 to the power P2 up to so on WQ to the power PQ. Then AB inverse will be equal to, just replace A by this product and B by this product and take its inverse. Then in the next step this product will remain as it is, and by Sawkeshu property this can be written as WQ to the power minus PQ, WQ minus 1 to the power minus PQ minus 1 up to so on W1 to the power minus P1. Now observe that as A and B are in H, so each U1, U2, Um and W1, W2, WQ are in U, and also this K1, K2, Km, P1, P2, PQ will be integers. So minus PQ minus 1 and minus P1 are also integers, and therefore this product will be a member of H, that is AB inverse will be a member of H, and therefore H will be a subgroup of group G. I have also written reason here. Now as for all ui in U, ui is clearly in H also, and therefore U will be a subset of H, and this implies U cap will be a subset of H, as U cap is intersection of, as U is in U cap. Now conversely, since U is in U cap and U cap is itself a subgroup, then it must contain all the elements which are described in the construction of H, and thus H will be a subset of U cap. Now as H is a subset of U cap and here we have U cap is a subset of H, therefore U cap will be equal to H, and so our required subgroup U cap will be a subgroup of group G containing the subset U, and U cap will contain all the elements of the type U1 to the power K1, U2 to the power K2 up to so on UN to the power Kn, where each Ui is in U and all these Ki's are integers. And this proves part A of this question. Now next thing is, if GUG inverse is an element of U for all elements G in group G and for all elements U in U, we have to prove that U cap is a normal subgroup of G. That is, this U cap is a normal subgroup of G. To prove this thing, we will consider an element, say U cap in subgroup U cap. Then for U cap in U cap, to prove that U cap is normal subgroup of G, we will show that for any element G in group G, G U cap G inverse is again an element of U cap. Now as U cap is an element in subgroup U cap, so U cap will be of this type: U1 to the power K1, U2 to the power K2 up to so on UN to the power Kn, where each Ui is in U. Now as Ui is in U and G is in G, we have for some integer n, GUI G inverse to the power n will be equal to GUI G inverse n times. We can write this as product of GUI G inverse n times. Now in the next step, G inverse G will be identity. So we get this thing, GUI G inverse. Here product of UI is n times. So we get GUI G inverse to the power n is equal to GUI to the power n G inverse, and this will be clearly an element of U cap, as each of these is element in U cap, and therefore we have GU cap G inverse will be equal to G U1 K1 U2 K2 up to so on UN K1 G inverse. We have just replaced this U cap by this product. Now again this can be written as, here if we consider identity, so this identity can be replaced by G inverse G everywhere. So this G U cap G inverse can be written as this G U1 K1 G inverse, G U2 K2 G inverse, G UN Kn G inverse. Now each of these is element of U cap, therefore we have G U cap G inverse is again an element of U cap for all elements G in group G, and this shows that U cap is a normal subgroup of group G, and this proves part B of this question.